Good day, everyone. We are back again. Like I promised you, this time we will do an exam question. So I took this question paper from the Limpopo Department of Education 2021 June exam. So I'm looking specifically at the momentum question. And let's read here and try to answer these questions. We are given a graph because in the previous video we were doing the graph. It says here, I hope you can see there, a ball R of mass 1,2 kilograms traveling at constant velocity collides head-on with a stationary ball S of mass 3,6 kilograms, as the diagram below illustrates. So this ball here of R was moving to the right and collides with this here, this ball S here, which was stationary, which means it was not moving. And here they show us it says the frictional force are negligible, so we can ignore the effects of frictional forces. It says here the variation with time of the velocity v of ball r before, during, and after collision with ball S is shown in the diagram below. In the graph below. They show us the velocity of ball R initial and during collision and after collision. So they show us three things here. This is before collision, this is during collision, this is after collision. So the negative velocity here tells us that after the collision, this ball here, this ball R here will move to the left. But if this graph here was like this and it never crossed to the negative y-axis, it means that after collision, this object will still move to the right. But because it crossed the negative y-axis, it means that the ball is now moving to the left. I hope you can understand that there. Let's look at the first question. It says, define in words the term momentum as used in physics. So what is momentum? We define momentum as the product of the object's mass and its velocity. So its P is equals to mv. You get your 2 marks there. Use the graph. So we are not allowed to use anything else but the graph. So it says use the graph to determine for ball R during the collision. So you're looking at this time interval only because this is during the collision. With ball S, the magnitude of the following. So we are asked to calculate the change in momentum. Let's do 6.2 here. If you don't mind, let's do 6.2 here. I hope you can see there. 6.2.1, it wants us to calculate the change in momentum. So what is the formula for change in momentum? So the change in P is equals to mass times the change in velocity is equals to, what is the mass of this ball? They told us here that it's 1.2 kg. Before you substitute in, you must make sure that everything is in SI unit. So we have 1.2. And what is change in velocity? We have a final velocity, which is -1. So it's -1 minus what is the initial velocity? Is +4. So it's -4 minus +4. So our change in momentum, let's calculate it here. It's 1.2 into -1 minus 4. It's -6. So our change in momentum is -6 meters per, sorry, it's not meters, it's kg per meter per second. So our change in momentum is in the other direction, and we can do 6.2.2 now. 6.2.2 let's do 6.2.2. It says calculate the magnitude of the average net force acting. So what is the average net force acting here? To calculate the force, we can, let's use the force equation or the force formula and do it. Is we will say F net is equals to change in momentum over the change in time. So it's equals to, we calculated the change in momentum. Notice how physics questions are set. You will need the previous answer to answer the next question. So if you got this wrong here, I don't think you'll get this right here. So make sure you get everything correct. You double check your answers and get those marks there. So here we are asked to calculate the average force. Remember that here, let me put it very well. And good. The collision started from 0.2 seconds and ended at 0.26 seconds. So how long did the collision take place? So the collision took place for, you will say 0.26 minus 0.2, which will be 0.06, but let me verify. It's 0.26 minus 0.2. Yes, it's 0.06 seconds. So the collision lasted for 0.06 seconds divided by 0.06. So the F net there is negative 6 over 0.06. I get an answer of negative 100 Newton. So this force here is in the other direction. It's negative 100 Newton. So what is the force that S exerts on R? Of course, it's positive 100 Newton. And we talked about this in the previous videos. And let's look at this here. 3.3. Look at 6.3 rather. Calculate the speed of the ball S after the collision. I mean, we have everything here. We can substitute in the conservation of momentum formula, which states that 6.3, it says m1 v1 initial plus m2 v2 initial is equals to m1 v1 final plus m2 v2. This formula is very long, and let's substitute in. What is the mass of the first object? Is 1.2. It was moving with a velocity of 4. We're given there 4 plus m2. We're given that as 3.6 plus 3.6 into 0 because it was initially stationary. So after the collision, we have 1.2 into negative 1 plus 3.6 into v. So let's do the algebra here. We will see 1.2 into 4. We will bring this to the other side, which will be minus 1.2 into negative 1, like this here. So we get an answer of 6. So let's say 6 divided by 3.6, and I chose to the right as positive, so my answer is 1.67 meters per second. But because they said speed, I will not give direction. But if they said velocity, then I will give direction. But here they said speed. So when they say speed, you do not give direction. When they say velocity, you give direction. Because speed is a scalar quantity and velocity is a vector quantity. And let's do the last question, because I think this question here comes almost all the time. It says using the the answer in question 6.3. So if you didn't get 6.3 correct, then I don't think this year you will get it correct. So you say using the answer in question 6.3 above and the information from the graph, deduce quantitatively whether the collision is elastic or inelastic. So here we are going to compare the initial kinetic energy and the final kinetic energy. So the initial EK initial, or the sum of kinetic energy initial, let me say the sum is equals to half m1 v1 squared plus half m2 v2 squared. So is equals to half into 1.2. What is the initial velocity? Is 4 plus half 3.6. What is the initial velocity? Is 0, but don't forget to square. So this here will add up to 0. I mean, this will multiply to 0. So the initial kinetic energy is half of 1.2 into 4 squared. So it's 9.6 joules. So before collision, we had a kinetic energy of 9.6 joules. So let's say the sum of EK final. We're going to compare the true values. And what do I need here? Okay, let's substitute in the equation. So it's half m1 v1 squared final plus half m2 v2 squared final. So it's equals to half 1.2 into, what is the final velocity? We're given there as -1. So -1 squared plus here you do not need to, you do not need to substitute in the signs, you just substitute in the values. So it's half 3.6. What is the final velocity? We got it here, it's 1.67. Here the signs do not matter. And let me find the answer there. It's half of 1.2 into -1 rather, plus half into 3.6 times 1.67 squared. So we got 5.62 joules. So since these two kinetic energies are not the same, therefore this collision is inelastic. And what happened to the other energy? Because when they collide, we hear a sound of them colliding. Like when this pen and pencil collide, you can hear the sound. Some energy is lost due to the sound. And when they slide through the surface, some energy is lost in the form of frictional force. So that's why we have two different kinetic energies here. So this collision is inelastic. And this is it about this video. I will see you in the next one where we will be doing another examples on momentum and impulse. I will see you next time.